Hello, YouTube. This is umils03. In the previous lesson, we basically brought up the idea of tuples, and we said that basically there are different types of data structures in Python, and there can be trade-offs between different data types. There can be different situations where you would apply different data structures, and clearly we've already spent a lot of time with lists, right? We've seen lists with the context of while loops, for loops. We've put them into our own functions. And then in the last video, we sort of started characterizing the differences between lists and tuples. So, one of the things we said is that lists and tuples, both can hold elements of mixed data types, and they can both be referenced by index positions. The big critical difference is that lists are mutable, which means that you can add, remove, and modify elements. With tuples, you cannot do any of that. So if you create a tuple, you could basically think of it as a constant tuple. You cannot reverse the elements, you cannot remove anything, you cannot append anything. None of that is fair game when it comes to a tuple. So we're also going to talk about two more types of data structures in this video. We're going to talk about sets and dictionaries. And so we want to be able to compare and contrast them. And ideally, we also want to be able to go back and forth between one data structure and another data structure. So just like in the past, how we've said that we can have a data type conversion basically from an int to a string, or maybe from a int to a Boolean. Remember, if we say bool of 2, that would be true, but bool of 0 would be false. We can also have data type conversions across data structures. So we can turn a list into a tuple. We can turn a tuple into a set. And then, we can go into kind of different directions with that. So we're going to see all these things. What we're going to spend the next 18 minutes doing is basically trying to understand this code that I've written. And actually, I have 150 lines, so we're going to have to move pretty quickly. But I want to demonstrate to you the similarities and differences between lists, tuples, sets, and dictionaries. And I think by parsing through the example code that we have here, it'll give me a chance to really demonstrate a lot of fundamentals in a quick and efficient way. So what we're going to do is, I guess I can review the concepts, right? So we already know a list is a collection of elements. They can be accessed by index position. And then, we said that we can go ahead and append, remove. We could say list of W equals X. And then also remember, we can insert an element into a list at a particular index position. Remember, there's also lists of insert of NX, right? And so that would insert, elements X at index position N, and then it would scoot all the subsequent elements one position to the right. With a tuple, we have an immutable collection of elements. So once a tuple is created, it can store any elements of any data types. We can also access elements by index position, but tuples cannot be changed. They cannot be modified in any way. And we denote them with parentheses, but then when we talk about passing an index position, to get a value out of a tuple, we still use square brackets, okay? With sets, we're talking about an unordered collection of unique elements, okay? So you would never have duplicates. You could never have a 4 and then another 4, okay? It would just be 1 4 in your set, okay? So no duplicates, and you also can't index, okay? So you wouldn't say set of 2, okay? There's no elements at index position 2. We're assuming that the elements are basically unordered, okay? They're not characteristically sorted. And we're going to denote those by curly braces, okay? And there's no index position, so I'm just going to make little curly braces there. And then for tuples, remember, we have just regular parentheses. And then for lists, we have square brackets, right? So hopefully that makes sense to you. And then if you try to add a duplicate to a set, it would have no effect. So if a set already has 4 and you add 4 in there, it doesn't really do anything. It doesn't change the set. It doesn't throw an error, it just doesn't change anything. So with a dictionary, those are also denoted by curly braces. What it means is it's basically a set of key value pairs. So what you have to do, you have to think of a dictionary as basically just being a set of elements where each of the element basically connects a key to a particular value. It's sort of like an input and output. You can almost think of it as a function. It's like each of the keys in your dictionary will map to or will have a particular value or solution, and we call that the value. Okay, so it's the value of each element. Okay, so if you have 16 keys, you're going to have 16 values. So there's a one-to-one relationship, and that's what a dictionary is. Okay, and that's basically all it is. It's just basically pairs of elements, essentially. One of them is the key, and it's like the input. The other one is the value. It's kind of the output. So the keys must be unique, and so you could not have two of the same key. So that's why we basically say dictionary is a set of keys rather than just, a set of key value pairs, right? Rather than just a list of key value pairs, because you could not have two keys that are the same, but you could have two different keys that map to the same value. And then keys in a dictionary can be ints, floats, strings, or booleans, but not lists or dictionaries. Okay, so hopefully that's clear to you. We have a sample list here. We just have 4 strings, and then we have 2 ints, and then a boolean. So we know bool of 0 is false. And what we're going to do is we're going to say sample list of 0 is equal to sample list of 0 plus s. That's going to stick an s onto corner. There's no problem with that. So we would say elements of a list are mutable. Okay, we can modify them. Okay, and then this will go ahead and reverse the order of the elements in sample list. Okay, so that makes sense. I think we've seen that once or twice before. This removes the element. This removes the element January from the list. Okay, wherever it might be, or I guess the removes the first occurrence, right? The first occurrence of the element January from the list. Remembering that the list is now reversed. So now, if you had 2 Januaries in your original list, it would basically be removing the second one, right? Because of line 27, we reversed everything, right? And then we can also, insert a particular value into a particular index position. Okay, and we've already seen that. And then just as another refresher, remember we can count the number of times a element appears. So here we would expect 0. And then for sample lists, we could go ahead and print the elements in the list. And then we could also figure out the length of the list, how many elements are currently in the list. And then one thing I never told you guys about, but one thing we also have that can apply to a list is a clear function. Okay, so the clear function is called on a list. It doesn't accept any inputs, but as you might be able to predict, it removes all elements from the list. Okay, so what we're going to do, this is just, and then I just wanted to say one more thing about sort of lists and strings. Remember that when we were talking about lists, we said that we could use the word in, right? And we could say, oh, print of 7 in W, and right, so that would return true if and only if the element 7 occurs at least once in the list W. Okay, it turns out that you always have to, we keep coming back to this idea that a string is a list of characters. So in works with strings as well. Okay, and it is case sensitive, but if you go ahead and try printing this boolean, either E in New York, okay, so that's certainly true, or F in fanboy, so both of those booleans would be true. Even if you have made this an and, then that would still be true, right? So then let's just go ahead and run. This is just our consideration of lists, and then we want to talk about the other data types pretty soon. But there's a lot of code that's going to be printed, and we just want to focus on the segments that we care about, right? So the first thing that we printed is the sample list.count of 333. Since 333 does not exist in this list, we get 0. And then we print all the elements in the list, and that's clear enough. Remember, corner became corners, and then we reversed the elements. And so that's why, the 8's shown up before the 5 now, right? And then it go ahead and said, okay, what's the length of the sample list? So we can obviously get the length of a list. And then it clears the list, and then it says print the list. And so that's why we have an empty list. Hopefully you can see that down there, sort of on the middle of the console output. And then we could say, and then we have this Boolean, right? So E is in New York and F is in fanboys. But what if we say F not in fanboys? Well, now we have a true Boolean and a false Boolean. So that will go ahead and evaluate to false. That's what you see right there. Let's also create a tuple. Okay, so now we are creating a tuple with parentheses rather than square brackets. Okay, so hopefully that makes sense to you. So this is a tuple, sort of similar, but not really, right? Now we can't change any of the elements. We can't add anything. So what we're going to do is we're going to talk about an exception, and we've talked about exceptions not too long ago, right? We had a couple of videos on it, and I encourage you to go back to lessons 17 and 18 if you're not familiar with this architecture. But if you say try, we're going to try to print, going to try to change a value in the tuple, right? So obviously this runs successfully, so will be printed. Clearly we'll see that on the console, okay? But this would, if this code were run, it would try to reassign the value in a tuple, and then that would basically produce an error, okay? And I figured out for myself what type of error it causes if you run a line of code like this, if you try to change an element in a tuple, and it's called a type error, okay? And so basically it's gonna detect that type error, and it's, instead of trying to do that, instead of attempting that line of code, which would cause the program to go haywire, it's just going to say print, oops, didn't work. Let's just print the first value, okay? And so then what it's going to do is it's going to say finally print sample tuple of 0, okay? So regardless of whether or not sample tuple of 0 gets updated, right? Either it gets updated because the try code was successful and then we print it, or it doesn't get updated because there was a type error, but we would still just go ahead and print sample of 0 regardless. So now what we're gonna go ahead and try to do is we're gonna go ahead and run it, and we have to keep up with the code. So now it says, gonna try to change the value on the tuple. Oops, didn't work. Let's just print the first value, right? And then we go ahead and get the 6. Okay, so that's why you see print sample tuple of 0. So that's the 6 right here, and we're keeping up with the console output. So you can go back and forth between the code and what you see down here. We're going to create a tuple with just one element in it. Okay, so at least we're going to try to do this. So this attempts to create a tuple with just one element, you know, which happens to be a string here. Okay, and so what we're going to do is we're going to say for q in singleton tuple, print of q. Okay, and we know that a for loop can access an iterable. So if you're talking about a list or a tuple or a string, those are examples of iterables. We can take a for loop through them. But what's interesting here, though, is that you actually see the letters of the word hey printed on different lines. Okay, so right now the problem is that singleton tuple is actually a string. So the elements are letters that are being printed on different lines, and that's probably not intentional. So what you have to do is you actually have to put a comma inside of your parentheses. Okay, so for a tuple with just one element, have an empty space after a comma. Okay, so that's basically just a little pointer there. So now if you go ahead and run the code again, now you don't get HUI, you do get the word hey. Now it's a tuple with one element rather than a string with 3 elements. Okay, so hopefully that makes sense to you. We're going to say master tuple 1 is equal to 2 times this other tuple. And so this is an example of multiple concatenation. We saw in the last video that that's fine. And then this is basically simple concatenation where we can combine one tuple with another tuple. And then if we go ahead and try to print those, indeed, that's what we get. So we get 8 for pizza, 8 for pizza. Okay, and then we get the 1, 3, moon, moon, true, moon, because bool of anything other than 0 and false is true. So it just goes ahead and combines the elements from the 2 tuples and returns a tuple with all the elements. We can get the length of a master tuple. So remember, master tuple is this 1, 3, moon, moon, true, moon thing, and we can get the length of a tuple. Okay, so obviously can get the length of a tuple just like, you know, just like a list. And then this is kind of interesting. So this says length of list of range of length of master tuple 2. Okay, so here's the length of master tuple 2. So if you say range of length of master tuple 2, basically that is something that would allow like a for loop to access the index positions in master tuple 2, right? Remember when we said for y in range of 4? And then we said at the beginning of lesson 13 that we could just make a list out of that range command. So this would actually be the list, and then you could get the length of that list. So really it's actually just going to be the same thing as the length of master tuple, but hopefully you can process this conceptually and figure out, you know, how we would nest all those words together and what it's doing. We can still get the index position of an element in a tuple. So we can still get the index position of an element within a tuple, and can still count occurrences of an element. Okay, so we had the 6 and 6 that was from lines 62 and 63, and then it's going to go ahead and print the index position of the element 3. And if you scroll up, it looks like that the first occurrence of it would be at index position 1, right? And then what you could also do is you could be counting moon. It looks like we have 3 moons, so that's why you have a 3 right there. We're going to have another try catch, right? So we're going to try to reverse the elements in the tuple. But basically, if we catch that there's an attribute error, which I just figured out for myself would be the type of error that would stop the program run if you try to reverse a tuple. So I just said, oh, that's what's going to be caught. That's what's going to be thrown. I'm going to catch it. So I just catch it and say, cannot reverse a tuple. Okay, so that's totally valid. We also have an easy tuple. Okay, so tuples actually do not need parentheses around them. Okay, so you could actually just create a tuple literally just by separating values by commas. Okay, and then you can say for y in list of range of length of easy tuple, you would print easy tuple of y. And so we would just go ahead and print the elements. So it says 8, 1, no way, Jose, true, true. Let's see, the true there, true, true, right? And then that's essentially it. Okay, and now we can think about sets. So we're sort of running out of time. So with sets, basically these don't allow duplicate elements. So if you try passing in 2 3s, let's go ahead and print the sample set. You just get 8, 1, 3, and interesting, okay, because the duplicates are sort of removed. And then we're going to try to print sample set of 0. But basically what we have to remember is that sets cannot be referenced, the elements in them cannot be referenced by index positions. So here we would just print no index positions for a set. This is an example of a successfully catching an exception. Okay, and then you can go ahead and add elements to a set. So this is how you do it. You call the add function and the remove function. So if you say sample set.add of 8, okay, no effect because 8 is in the set already. Okay, and but add of 10 and add of 12, that would be fine. Okay, and then this removes the sole occurrence of 3. Okay, so if you remove an element from the list, literally any occurrences of that element would be gone, right? Because we said the elements have to be unique. So if you remove it, then literally it's gone. Okay, what we're going to do is we're going to try to say sample set dot remove of this element. Okay, so this is a long string and it says this element does not exist in the set, I promise, right? And obviously this is not an element to be removed from the set. So it would produce a key error if you wrote a line of code like this. But if you put it in a try block and you catch it, you could just print the key you tried removing doesn't exist here. Okay, so hopefully that makes sense to you. And then we can print the sample set, okay, and you can see that the 10 and the 12 made it in and that the 3 comes out. We can also have another set. So what if we have 7 and 10? If you say one set dot union of another set, it's basically the collection of all unique elements that exist in at least one of the 2 sets. Okay, if you say intersection, this is the collection of all unique elements that exist in both sets. Okay, so if you go ahead and say print my union, right, we had the 7, 10 list, and then we also had this 1, 8, 10, 12 interesting, right? So if you go ahead and do the union, only the 7 comes in because you already have the 10. But then if you do the intersection, the only number you get is 10 because that's the only number that was in sample set and another set. So that's the difference between union and intersection. You can call those to assess the relationship between 2 sets. Okay, and then you could basically say another set dot remove of 10, and then you could say print bool. What if you want to call the is_subset method? So if you say another set dot is_subset of sample set, this returns true if all elements of another set exist within sample set. Okay, so it would basically look at all the elements in another set and say, do all those elements appear in sample set? And so basically this Boolean is telling us no, because if we look at another set, remember we had a 7 in there, but there was no 7 in the original sample set. So that's why we get the false there, right? And so this function returns false, and then if we have bool of false, that's just false again. We're probably going to run out of time to talk about dictionaries, but I'll introduce the concept. So we have key value pairs here. Okay, so these are keys A, B, C, and D. These are strings. And so basically if you say print sample dictionary of C, basically your index positions could be arbitrary now. Your index positions are like keys rather than just positive numbers, 0, 1, 2, 3, 4. So if you say print sample dictionary of C, you get 3 because 3 is the value associated with the key C. And then you can redefine the values at particular keys. So if you say sample dictionary of A is 100, and then you try printing sample dictionary of A, instead of printing 1, it's going to print 100. So we can reassign the values of keys in a dictionary. Okay, so that kind of makes them mutable. It makes them a little bit more like lists than tuples. What if you said sample dictionary of E is equal to sample dictionary of D plus 1? So we can basically define new values for new keys in our dictionary. Okay, and so there's no E key in this dictionary, but we're just going to say, hey, I want you to create this key E, and I want you to basically give it this particular value. So what's the value? It would be the value of key D plus 1. So it'd be 4 plus 1, which is 5. So then it goes ahead and prints the sample dictionary, and you see all those key value pairs with the E5 included. There's a few more things to say about it. I want to talk more about data type conversions. Usually we have to spend a little bit of the next video sort of finishing what we talked about here, but we covered most of it. You got the lists, you got the tuples, and you got the sets now. And so we'll have to say a little bit more about dictionaries in the next video, but hopefully you enjoyed it. From Umils03, thanks for watching, and please subscribe.